solution through this pipe, and when the sol is with the there is no turbulence at all, we drain the solution slowly with a certain speed depending upon this equation where the draining speed is directly proportional to the physical thickness of the coating. So we can tailor the thickness. 18 Hz high energy gamma rays it can protect, and other properties, that is transmission increase with respect to substrate 7%, pencil hardness 5H, quite hard, that is mechanical property is good, adherence is good, static water contact angle we measure 95 to 100 degree, and present status we have already patented this process in Indian patent, and this is the transmission curve where we can see the transmission in the visible region increase nearly 7%. And where is its application? This is the coated glass block 400 into 100 millimeter. This is the window of hot cells where radioactive reactions is going on. The operating personnel can operate the whole system outside the window that need to protect. 7 kinds of glasses are there in each window. Our glass, we have supplied BRC Mumbai nearly 24 metric ton, and that glass is used here for this window block. And here, due to this protection, the operating personnel can easily work, safely work, and we can get the radioactive reaction successfully. Now, I am coming to another coating, that is hydrophobic, super hydrophobic and anti-reflection coating on KDP crystals and also quartz glass for phosphate laser glass application. For this, we have fabricated or we have designed the composition. It has lot of calculations and lot of calibrations is required to get the actual precursor sol composition. We have taken the mesoporous silica where the porosity is nearly 44%. I will show the curve. And here the sol which contains the 308% of silica generated from tetraethyl orthosilicate in presence of ammonium hydroxide and ethanol can form the colloidal solution, and through this colloidal solution we can get the physical thickness 120 nanometer and the refractive index very low 1.2, and this is very much usable for getting the anti-reflection property on the surface of glass. And here is the porosity data. We measured it spectro ellipsometry method in our institute. It is a high value equipment where the thin film porosity can be accurately measured, and we obtained the porosity value 43.6%. That means this is the adsorption desorption curve which is popularly seen, which is always seen in our BET isotherm, but it is not BET isotherm. It is the spectroscopic atmospheric ellipsometry porosity curve where the adsorption desorption isotherm can be generated. And from this curve we can calculate the volume porosity. The film contains 43.6% volume porosity. Therefore, the refractive index can be tailored or can be decreased. And it is the type 4 characteristics of mesoporous film. And the other coated substrate, that is the quartz silica glass anti-reflection coating, the block, it is the dimension 200 millimeter to 150 millimeter and 20 millimeter size. This is the transmission spectra. You can see that the transmission 99.8%, nearly 100% transmission for this very thick, that is 20 millimeter quartz glass, and it has the other properties also, that is the its pencil hardness is high. Most important for laser fabrication is the laser induced value of that is called LIDT, and it is also quite high, 9 to 10 joule per centimeter square. All these properties are required to get the optics for laser fabrication. Now, this is also one of the component of laser, that is the potassium dihydrogen phosphate coated with super hydrophobic anti-reflection coating. This is the transmission curve where we can get the transmission 97% at 1054 nanometer, and also the LIDT value that is laser induced transition, that is 18 to 20 joule per centimeter square, and where the first layer we have deposited the protective coating, because KDP is highly sensitive to moisture. So first need is to deposit the protective coating. Over it, to increase the transmission, we need to deposit the anti-reflection coating. So combining the two coating, we can get the overall coating for KDP crystal. Here is the air coating, that is anti-reflection coating on laser rod, that is very much rich neodymium phosphate laser rod. We are also developing in bulk quantity, and with collaboration of RRCAT BARC, and this laser rod is the solid source of neodymium phosphate laser, which is called high power laser for fission and fusion reactions, and we can reduce the reflection over 2% by using this coating. Now coming to the HR coating, high reflection coating, this is the overall overall parameters that we have to tailor. This is the common formula, that is HL to the power n is to H, where number of layers will be always odd in manner, because this is, if n is 2, then plus 1, 3. So HL into H will give rise to the high reflection, that is mirror, and we by soil gel process deposited the 721 numbers of layers and get nearly 100% reflection at 633 nanometer, and the coating has also enough abrasion resistance, because that means the coating cannot be peeled off. So it has the capability to use for fabrication of laser. Here is the details, that is, this is the coated HR coated glass block, and this is the FESM, cross-sectional FESM, where we can see the stacked of porous silica, silica zirconia, porous silica, silica zirconia, up to 21 layer we can deposit it, and this is the elemental distribution showing the silica, oxygen, zirconia, and the fringe is showing the presence of that element, and from the EDAX spectra, and using the FESM atomic microscope image, we can calculate the roughness, and roughness is nearly 4 nanometer. And the most important is the surface reflection. The surface reflection at normal incidence, we achieved nearly 100%, 99%, over 99% with below 1% transmission. That is, this product can be used as a high reflector in this laser system. And now I am coming to my next activity, that is the solar panel coating. Solar panel coating market widely is very emerging, because nowadays the unconventional energy source is very much required, because our fossil fuels will be in near future, we can't use this, because the deposition is not so high. Therefore, solar energy, wind energy, tidal energy, this type of non-conventional energy is very much required. But in the solar panels, where we use the solar panels that may be corrugated by millimeter texture, by nanometer texture, with the pattern, solar energy can trapped. And at the same time, if we deposit the anti-reflection hydrophobic coating, we can generate the, we can increase the transmission, as well as the surface of the panel can be easily cleaned by using the water. Because our environment is dusty, and bird drops as well as the particles generated from the environment can be deposited, and that can be cleaned if the surface is self-cleaning, that is by deposited with the hydrophobic coating. Here the light trapping phenomenon, as we know, this is various generations of the solar glass is available. Now we are at the nanometer scale textured glass, and in this nanometer textured glass, our efficiency of solar cells could be much higher, but the glass availability of this solar cover glass is not so high in the market. Now coming to the for making this anti-reflective cum self-cleaning coating, we need to deposit two layers. First layer is the anti-reflection coating. These are the details of the fabrication, and here is the hydrophobic coating. So combining these two coating, we can get the anti-reflective cum hydrophobic coating. And here is the facility that we have been created indigenously at our institute with the sponsorship of DST, TBD, and this facility consists of substrate washing system, deep coater, and near infrared heating system. Here we are not using any conventional furnace, we are using only light based furnace, that is infrared heater. And in this furnace 3 kilowatt 12 numbers of tubes are there, which is the source of which is the heating source. And this is the details of the various equipments, that is, it is the tank where the solution has been kept and the sample is dipped into it and withdrawn at a certain speed, as I have shown the equation. And this coated substrate is annealed within this furnace, that is the NIR heating system, and we can get with using this facility 5 feet by 2 feet size coated glass block, and we fabricated the solar panel in our and installed in our rooftop since 2018 and getting 1 to 1.5% more higher power in compared to uncoated glass block. And this is also very much helpful to clean the surface easily because of the hydrophobic in nature, where static water contact angle is 120 degree plus minus 3 degree. Now the last part of my talk, that is coating for healthcare sector, super hydrophobic cum antibacterial coatings on fabrics. During corona period, we have done this type of work on fabrics for medical purpose, and here is the details how we can get the super hydrophobic property of any substrate. That may be the flat glass, that may be the corrugated glass, that may be the cottons where the porosity and the undulations are there. Actually, that governs depending upon various equation, and this equation, Cauchy-Boxer's equation, where hierarchical surface roughness is very much required to get this property. And combining with this hierarchical surface roughness, in presence of low surface energy material, we can develop permanent super hydrophobic surface on any of the substrate. And this formula we applied and we developed the super hydrophobic coating on cotton fabric. So this is the details, that is the morphology and chemical structure or composition is fully dependent to get the super hydrophobic property of the substrate. As you have known, lotus leaf, which is popularly known as which surface is super hydrophobic because of the presence of hump-like structure and the wax-like material, and that two combinations can give rise to the hierarchical surface and also the low energy material, that is wax, and giving rise the super hydrophobic surface. So these natural phenomenon can be mimicked in our practical application, and we did this. Here is the self cleaning. It can be possible through creating super hydrophiling, that is the static contact angle below 10 degree, and super hydrophobic surface, the water contact angle above 150 degree. And here is the details of antibacterial, antimicrobial property using S. aureus and E. coli because of the presence of AZO, that is silver doped zinc oxide, which is very much known for its antibacterial property. When light falls, so free electron generates, and combining with oxygen or water, it can produce the radicals, that is OOH dot or O2 minus dot, and these are the precursor to kill the bacteria, to kill the microbes, and can act as antibacterial coating. And self-cleaning property, we tested it by using methylene blue as a dust, and we fabricated 1 meter by 1 meter size cotton fabric or PPE fabric, and this is the contact angle 160 degree for cotton fabric and 152 degree for PPE fabric, and it has other unique features, that is coatings are stable up to 50 cycles of laundering and sandpaper abrasion, antibacterial, that is E. coli, S. aureus, and antifungal, S. candida albicans we have tested, and it shows 99.9% growth reduction efficiency and stable antibacterial and antifungal activity after 50 cycles of laundering and abrasion. With this, I conclude my talk by saying that functional coatings deposited on different substrates by sol gel process can meet the demand for strategic energy and health sectors, and we can fulfill and we can make Atmanirbhar Bharat. This is the message from myself, not only myself, for all researchers of our country, because we have to make our raw materials ourselves, and using these raw materials we have to develop the products which we are importing day by day. We have to stop that and make our country Atmanirbhar. Thank you very much.
Thank you so much, sir, for spreading such immense knowledge in this functional field of functional coating for strategic energy and health sector. Now, I would like to invite questions from my audience, yes, and also from dignitaries.
Hello. Thank you. Important topic, at least for me, because I told about the mothballing. You know, many reactor, different type of reaction is taking place with the chemicals. So for that, some corrosion developed in due time. I have seen ceramic these reactors. So I think you can suggest the lifetime, how long it can survive the chemicals inside a reactor.
Yeah, very good question. Actually, this type of coating is called anti-corrosion coating, but in my talk I didn't cover it, but we have developed it, and we measure the properties, and that can be usable of your application. Thank you,
sir.
I have one question.
Yeah, please.
When you say anti-reflection, so anti-reflections for all wavelength or any specific wavelength of light?
Yeah, it is an excellent question. Actually, as per the optical design, quarter wavelength optical design or non-quarter wavelength, that is lambda by 4, quarter optical design.
Quarter wave plate.
That is lambda is the designed wavelength, at which wavelength you need maximum transmission. Am I right?
Yes.
Yeah. So, what I have shown, N1 D1 equal to lambda by 4.
That is what I am asking is like, so you have
I am giving that answer.
The thickness of
thickness,
determined
thickness,
by the lambda, right?
Thickness and refractive index is the main precursor to shift the wavelength maxima at your choice.
That's all I'm saying. So, another question is like, so anti-reflection and the hydrophobic, both at the same time, right? Hydrophobic coating and anti-reflection.
No, I have shown that 2 layers. One is anti-reflection and another is hydrophobic. Not
so the hydrophobic surface is not anti-reflection.
No, hydrophobic surface is not anti-reflection. What we have done, we have first deposited the anti-reflection coating, over which we deposited the hydrophobic coating, maintaining the refractive index and thickness which is desired to keep constant the anti-reflection property.
Okay, thank you.
Yeah, please.
So when you are regarding your coating, So all your coating material are transparent.
No, not always. For cotton fabric or PP fabric, we need not that. For optical purpose, optical materials or optical substrates, optical objectives are there. So accordingly, we have to select the chemicals, we have to select the raw materials to make it transparent.
Okay. Next, another one. That is percentage. You say that 48 or 44%, vacuum. You're putting vacuum 44%.
No, porosity nearly 44%.
So
yeah.
What is actually
Volume
if,
porosity.
If your porosity increases, then what happens? If it increase, your efficiency will increase or decrease or your efficiency decrease?
Yeah, this is a good question. We have
And
made
also
the particle
mechanical stability
right.
at that time.
We have made the particle spherical in nature. There is lot of data, but it is not possible to show all this. The particles are spherical in nature. If we arrange 6 balls, we can get one
Inbuilt.
hexagon.
Yeah, yes.
Okay, and these hexagons, through this hexagon, the light can pass.
Packing.
Yeah,
Yes.
packing. That is a packing of the balls like this. This mechanism is persist here, and the pores are nearly 44%, and size is nanometric. That is 12%. Within the nanometric force or nanometric dimension of the particles, one can make the transparent layer or transparent body. If provided that if the grain boundary is not so much, because if grain boundary is very much influensive towards the transparency of the material. If the grain boundary is not so prominent and you made the particle size within the nanometric range, within the visible region basically, then you can get the transparent material.
So BAT analysis is not good.
BAT analysis is for powder system, bulk material, but for thin film system, spectroscopic ellipsometer, that is called atmospheric ellipsoporosimetry measurement is the only way.
Okay, high frequency.
Right.
Okay, good. Thank you.
Thank you. Yeah, please, ma'am.
So you have shown some super hydrophobic structure.
Right.
So does it depend on the dimension of the structure, or it's just any zigzag micro nanostructure?
No. It is definitely required. According to the Cauchy-Boxer equation that I have shown various models, Young models, Boxer model, Cauchy-Boxer models, there is a model, various models to generate the undulation over the surface. So Cauchy-Boxer's equation model is related with the heterogeneous surface roughness, that is called hierarchical surface roughness. That hierarchical surface roughness is very much required to generate the super hydrophobic surface, and that is not completely stable at all, because with time the water droplet that is residing over the bump or over the undulated region feature can penetrate with time. So to make it stable, that is the permanent superhydrophobic, we need to deposit low energy, surface energy, organic chemicals. Sealants are mostly used in this purpose. Fatty acids are mostly used in this purpose. Fatty amines are mostly used in this purpose.
What is the typical dimension of this kind of structure?
This is not a dimensional dependence. This is always same. For it is a monomolecule, that is only molecule, and you can polymerize as per your requirement, and also it depends upon the it can change the thickness of the layer, na? So you have to optimize it. What thickness you need, because optical coating, both physical thickness and diffractive index, which multiple gives is the optical thickness, we have to make it. So there is the boundary at which wavelength you need, and that depending upon that or accordingly you have to fabricate or you have to choose the material and make the thickness and refractive index.
Thank you.
Any question from student corner? I will be happy. Thank you.
Thank you so much, sir, for sharing your wide work experience with us. And to thank him, we would like to felicitate him with a token of appreciation and a memento. For this, I would like to call upon Sri Dilip Kumar Bera to hand over the token of appreciation and memento to Dr. Shunir Mol Jana. Next, we have another eminent speaker with us, Dr. Devdulal Shaha, Senior Scientist, Functional Material and Devices Division, CSIR. Sir, the session is all yours, and I would request, sir, to please kindly precise your talk within 15 minutes, sir.
Okay, but where my talk? Slides. Thank you, madam. Thank you, Jana Babu, to invite me here. Thank you, my seniors and my students and ladies and gentlemen. Okay, thank you. My talk is based on nanopore effect on the capacitive response towards alumina, towards moisture sensing. Actually, moisture and humidity sensors are based on polymeric type, which is market available and price is very less, very, very less. You see in all clock, there is a moisture sensor is there, in watch, moisture sensor is there, and price is very less. But we developed a special type of moisture sensors for special applications. Now, these are sensors, the different types of sensors work in my lab, like gas sensors, heat sensors, sound sensors. Most of the sensors working in our lab for different scientists working in that. I am working the humidity and moisture sensors through dielectric and spinel type materials. So in a sensor, some measurement like any measurement types, gas or moistures or any other things, when the response to sensors, then some output is there. Like voltage, current, resistance, capacitance, etc. Our sensor is based on the capacitive types, and the capacitance is basically to parallel electrode inside these sensing materials. So any sensors, either humidity sensors, gas sensors, biosensors, some special characteristics there. Every sensor is these characteristics follow, like sensitivity, cross sensitivity, resolutions, and every point is satisfied and repeatability, otherwise the sensor is not good enough. So different types of moisture sensors is there, capacitive, resistive, thermal, conductive. We work in our lab the capacitive type sensors. There is a 12 physics. There is a capacitance C. See, the capacitance is directly proportional to the epsilon R. Epsilon R is the dielectric constant of the materials, and the D is the distance between two electrodes, and S is the effective electrode area. Means if it is a thin film, then sensitivity is high. If it is a dielectric constant of the materials is high, then sensitivity is also high. So when moisture condensation takes place in the porous structure, then the effective dielectric constant, the epsilon R, changes. So condensation is the primary phenomena, and tailoring of pore is one of the major phenomena. So now is a moisture molecules, the diameter is 1.58 angstroms. So diameter is very less. So if it is a condense in a porous structure, the porosity must be nanopore in size. Otherwise condensation very difficult to condense. So the water molecules having 6 degrees of freedom. So when condensation take place, in a porous structure, then the phase change means vapor state to liquid state. Then water molecules, actually the dielectric constant of the water is 80. So when in a particular material, especially for spinel or dielectric materials, the constant dielectric value, when condensation take place, some addition is there. Means water molecules dielectric constant with material dielectric constant, the composite dielectric constant changes. So condensations, more condensation take place inside these dielectric materials, more capacitance is increases. This is the principle of this material. So now the porosity, the moisture content in the air, and contact angle is another parameters. Then excitation frequency also is required. So everybody know the contact angle. If the contact angle is less than 90 degree, then more adsorption take place on the surface. So now question, why ceramic? Why not polymer? Actually polymer having two difficulties there. First of all is easily degraded. And second point is the temperature stability. The polymer materials cannot stable more than 50 degrees centigrade, but there is a special applications. I will see the application area. The special application temperature more than 100 degrees centigrade, 200 degrees centigrade. In that temperature regions, moisture sensor is required, and there is no option to use the polymer sensor. There is a special ceramic based sensor is required. That is why we work on ceramic based sensor. So these are materials: titanium doped magnesium from the spinel variety, the functional carbon nanotubes, and all are the spinel materials. And above all, the alumina is a very specialist materials because the condensation value is more high than the other materials. So we developed three configurations. One is thin film variety, thick film variety, and another is a cylindrical types. For special applications, the heating arrangement is there. So if it is a recovery is faster, there is a heater is required. That is why the cylindrical sensor is required. So now there is a shortage of time. First part is development faster, then go to the application. This is a substrate development. I am not going into details. And the tube also first substrate development, and the sensor development. So this is a tube inside. Then we are coated with gold electrodes. The gold is although gold is the costlier material, but gold is the inert in nature. Everybody know due to inert pair effect. So we used as a gold, and then used as a gamma alumina as a sensing layer, then top electrode. So there is a two electrode, one is bottom electrode and then the gold electrode, the top electrode, and inside this porous structure of the gamma alumina. The gamma alumina is a sensing layer, it's a nanoporous structure. So the Sol-gel process already explained my colleague in previous. So this is a relative humidity generation for solid solution. The universal you generate the relative humidity, not required for any standard solution. Is you make in a lab for different salt and generate the humidity for a particular temperature. So salt solution also prepared by aluminum sec butoxide. This is the aluminum sec butoxide hydrolysis to form say alumina salt, and then refluxing, and then we got the coating solution. And then similarly we develop the bottom electrode through gold electroless gold plating process, and this is a coating process. There is a deep coating unit is there. The sol is prepared is one side, and the bottom electrode prepared is another side. Then the deep coat inside the sol, and after curing 80 degrees centigrade, then top electrode is there. Then ultimate composite firing the 900 degrees centigrade. So this is a overall proposed, and our sensor operate up to 150 degrees centigrade, and this type of sensor is not market available. This is a project based work as the NTPC project and already deliverables. I will explain later. So this is a planar type variety already developed and demonstrated in BRC, also NTPC. I'm going to details. So these are development part already developed here. CRI cylindrical types already developed. Now this is a specification. We range 1 to 100 ppm 100 ppm of the moisture detects in transformer, and the temperature up to 150 degrees centigrade, and the options is the digital LED display. Also recently we developed in wireless communication system. And this is a film surface characterization. These are because the porosity is a primary phenomena. So we see the porosity through AFM, through TEM, through FESCM. Every picture shows the porosity. So also contact angle measurement also there. This is a contact angle of 60.2. So this is a electrical characterization part. With respect to the time, see the capacity is steady state because the aluminum is a very stable materials. Also the hysteresis plot we measured, Now sensitivity, also the response and recovery time also measured. This is the characterization part. And finally, prototype also developed in our lab. 2 prototypes already supplied to the industry, Baraipur. Actually, they also work on the transformer filter unit. That is why 2 prototype unit already supplied to transformer. And this is some prototype also developed. Now, this is a lot of applications. So, I'm here is that I focus in 3 applications here. One is the dielectric oil, another is the agriculture, means food, and third one is nuclear industry. If the time permit, then I explain 3 applications already demonstrated and field trial already there. If it's not time permit, then I will explain 1 application only. So now, first application here. The trace moisture detection is the oil field transformer and gamma alumina sensor. Gamma alumina means alumina having some polymorphic forms. Gamma is one of the forms which is easily developed nanoporous structure. That is why we choose gamma alumina through sol gel route. So, just a minute. See, this is a transformer. This is a universal graph is there. In transformer oil, the dielectric breakdown voltage depends on the moisture contents. So, sometimes we see in our roadside, sometimes transformer bursting. Because why transformer bursting? Because slowly weathering of the transformer, moisture leakages inside this dielectric oil, and more water reabsorption inside this oil, then down the dielectric breakdown voltage. As a result, certain moisture content is more than 30 or 40 ppm of moisture inside this dielectric, inside this transformer, then transformer accident take place. So, what is we work? So, this phenomena is the moisture content. Water is a dipolar molecules. Water content is higher in higher concentration. Then through hydrogen bonding, then hopping conduction take place. That is why accident take place. This is inside this transformer phenomena. So now, this is a unit. Actually, this is a transformer filtration unit. This is a collaborative project. Is a industry, the Baraipur plant, and they develop this type of instrument for transformer oil filtration. Actually, transformer oils, if you see the price is as much as petrol, means more than 110 or 20 per liters. So, very big transformer required thousands liters of oil. So, once you use, you cannot throw it. So, you recycle it. How to recycle? First we remove the moisture through this type of filtration unit. As this is a prototype filtration unit. They sell big filtration units. And every oil refinery, electricity board, coal mine, thermal power plant, everywhere transformer is there. So, this type of instrument they supplied everywhere. So, one of the prototype units supplied to CGCRI for our testing purpose. So, free of cost. Now, just a minute. Slide is not moving. See? Yes. No. Yes. So, the already 2 meters supplied to the Nisha Engineering Corporations, Baraipur, and tested in the Nisha Engineering Corporation for field trial. But initially, we supplied to flat type sensors. But after trialing, see the recovery is very problem, because lot of moisture condensation take place on the surface. So recovery is very difficult. So we changed our design from planar to cylindrical, as well as inject the heater. So recovery is faster. This is our meter, the planar to cylindrical already developed, and this is a testing part in CGCRI. So all our testing part. This is also dielectric breakdown voltage measurement unit is there. So this is finally we measured and supplied to Baraipur, this MSME company. Now the second part is actually this project is based on the NTPC. NTPC required that this type of moisture sensors for their different plants. All over India, more than 50 to 55 thermal plant is there all over India. One of the West Bengal is the Farakka. So their requirements that the transformer is the far away from the control room. So we measure the moisture of the transformer every time, 24/7. So we develop this type of sensors and mounted in transformer. This is outside the transformer here. This is our sensor part inside this transformer, and this is a control unit in a control room. and the distance is approximately 700 meters. Up to 700 we tested in an NTPC plan. This is a Faridabad plan. So these are meters. Initially 3 sensors is installed. The 9A, this is showing the 26 ppm, and the 9B showing 5 ppm. So their limitations is there. Though there is a 2 types of transformer, step down, step up transformer. So this is step down transformer. So according to, they measured the moisture. If the moisture contains their limit, then the transformer stop down and the recycle this oil. So what is the current process? Current detection technique. Current detection technique is the offline process. Offline process is the Karl-Fischer technique. Karl-Fischer technique is offline process. If you take water oil aliquot and send to the lab, and in the lab there is a Karl-Fischer process. They detect, they measure the moisture content. If the moisture content is more than their limit, then they stop down the transformer and that changes oil. But this is a online process. Every time you see in your control room, there is a meter is there. So every time we detect the how amount of moisture present inside this oil. This is the beauty of this work. So already we shown that everywhere is a transformer is required. Now the second application. Madam, is time is permit, then I will explain the second part. Okay. Now the second applications is LBB application. LBB means leak before break applications. This is a very good application for nuclear plant. See, so this is a superheated steam generator. This is a project between Jadavpur University, Thermal Power, Jadavpur University, BRC and CGCRI. There are three mode project. This is a superheated steam generator and this is a pipeline is there. So if any flaw inside this pipeline, then accident take place. This is known as LBB, leak before break. So the steam, superheated steam is a 10 bar pressure and the 350 degrees centigrade of the steam go to the fuel plant, uranium plant. This is a motto of this work. So this is a pipeline. So we mount some sensor. Actually there is a pipeline and outside that is a 6 inch insulation is there. So our sensors mount inside this insulation 1 meter interval and this is a zigzag type. So then if the catastrophic failures inside this take place of this tube, then suddenly our sensor senses the moisture because the pressure inside is the pressure 10 bar pressure, but outside is a 1 bar pressure. So condensation take place easily. So easily take place the condensation in our sensors and signal go to the control room. So this is a lab setup. We tested 1 bar pressure and finally we tested in Jadavpur University 10 bar pressure. Actually this is a heat power university and Jadavpur University. Actually this type of setup is not in our lab. This is a superheated steam generator. But we develop sensors and electronics. And Jadavpur University in heat power lab, their setup is there. So in this unit, this is superheated steam generated inside this line. And this is a prototype type. This is a 6 inch insulation is there and our sensor is inside that. And this is electronics connected to the controller. And when this valve is open, then superheated steam comes this line and touches to our sensor because this area is 1 atmosphere, which means room atmosphere. And this is a superheated steam 10 bar pressure. So after that, this is a diagram of the sensors and this is a Teflon tube because the height is required and top of this part is electronics is there. So this is the overall part, this is the electronics part and this is a sensor part, electronics part is a control unit and tested in Jadavpur University and finally tested and so there is a 5 sensor response and 1 sensor slightly response. Actually in LBB concept, your sensor senses within 10 seconds. Within 10 seconds senses and your output go to the control room within 10 seconds. But most of the sensor are senses within 6 seconds. So now end here. Thank you all of you.
Thank you so much, sir. Now I would like to invite questions from our delegate as well as our listeners. Please come forward with your query.
In transformer, we developed 100 ppm, 1 to 100 ppm, but most of the NTPC persons is there, their detection limit is maximum 25. But our sensor senses to 100 ppm. From 1 to 100 ppm moistures, we senses. If you want more than that, we also tailoring this material, actually tailoring the porosity by applying, by adding some pore former materials like buckyball, means fullerene, carbon nanotubes, graphene. So we developed the porosity, like conical pore, cylindrical pore. Actually, pore morphology is very important for sensing phenomena. If it is a conical pore, then the sensitivity range is higher. If it is a nanopore, in cylindrical type, the sensitivity range is lower. Means if you want 1 to 10 ppm, we want 1 to 10 ppm for a particular application, especially for medicine industry. In medicine industry, moisture content is very less, 1 to 10 ppm. So in that case, we developed cylindrical pore, not in the conical pore.
Okay, thank you. So your ceramic sensor.
Yes.
But you start with alumina, gamma alumina.
Gamma alumina, gamma alumina is
it
ceramic
purely,
material.
Ceramic, but no other things are there.
No.
So purely it is on alumina compound.
Actually, alumina Al2A3, alumina having some lot of varieties, gamma alumina, alpha alumina, theta alumina, beta alumina.
Idea of ceramic is a little bit wider.
Ceramic, actually alumina is a brought and bond of the ceramics. You go to the Constables, you go to the alumina bricks, everywhere alumina is required. So ceramics is one part, main component part of the ceramics, alumina. Without alumina, you cannot develop spinel. So alumina is the primary materials of ceramics. Ceramics having lot of varieties, non-oxide ceramics, bioceramics, lot of varieties there. But alumina is one of the major part in the ceramic materials.
Thank you.
I am just adding one word, that is alumina is major part. Alumina silica. Alumina, without alumina silica, we can prepare any concrete wall or any ceramic material. So typically, yeah.
Yes. Yes, it's ceramic.
Yes.
Actually, ceramics having different types of definition is there.
Actually, you have not told anything about the static electricity charge.
Yes,
when,
sir.
When the powders are flowing, there is a problem I have seen in the industry, the fire,
Yes.
static charge development.
Static charge development.
Yeah, friction. Due to friction. Because that problem is there and fire takes place many times I have seen, particularly when aluminum silica, these are flowing in the tubes.
Okay.
Actually, alumina silica is dielectric material. That's why electrical conductivity is not there. That's why we are using it.
Thank you so much, sir. Now
Okay.
we would like
Thank you,
to
madam.
felicitate Dr. Devdulal Shaha with a token of appreciation and a memento. For this, I would like to call upon Sri Dilip Kumar Bera to hand over this token of appreciation and a memento. Next, we have another eminent speaker among us, that is Dr. Shanut Kormokar, Professor, Department of Physics, Jadavpur University. So I would like to request Dr. Shanut Kormokar to come forward for his lecture.
Right? Can I start? Yeah. Okay. Good afternoon, everyone. First of all, I'd like to thank organizer for giving me the opportunity to speak to you. And this talk is going to be a little bit different different from ceramics. This is something related to a disease. Okay, so leishmaniasis, that is we call it kalajor, that in that disease. Okay, so this is basically a talk about the cholesterol, how it affects on the interaction of a kinetoplastic protein KMP11, okay, with anionic phospholipid membrane and implications in leishmaniasis. So I will just give you some kind of brief how the leishmaniasis occurs in our body and what is the role of this particular protein in this disease. Okay. So because I am not going to give you many technical details because of the time constraint, I will give you some brief popular level kind of things so that you will get to know what kind of work is going on. Okay. So KMP11, that is a protein which is expressed